All right, a very quick note about units. Units are important, obviously. It's helpful to keep up with your units throughout the problem. I always say that it can help point out errors, but it can also help if you're not quite sure the equation. Is this 1 half mv squared or just 1 half or just mv? If you look at your units could help you throughout the problem because units must be homogeneous. What does homogeneous mean? Means same throughout the equation. The same units on the left-hand side as on the right-hand side of your equation. The same units for every term. All right, just be consistent. Be consistent, right? Units can help point out errors. This class more than others. Units might be a little bit harder in this class for thermodynamics, and they are important and tricky sometimes. Like I said, we're going to be looking at lots of different types of energy coming in, lots of different types of energy going out. You've got to make sure if we're summing up this energy plus this energy plus this energy, it's got to have the same units. The units for energy are joules. SI units are joules. Joules are Newton meters, Newton times meter, right? And I'm not afraid to use English units. We'll talk a little briefly about English units too. But for SI units of energy are joule. Work, when I think of work, I think of force times distance. What's the unit of force? Newton. What's the units of distance? Meters. So as long as we're in Newton times, so as long as we're taking a Newton times a meter, then we're good. We're in joules. But if we're taking a Newton, and if the distance was in millimeters, we need to be careful. If we're looking at kilonewtons, we need to be careful. A Newton times a meter would be equal to a joule. For potential energy is mgh, mass times gravity times height. And mgh would be kilogram times gravity. That's an acceleration of meters per second squared times a meter. Did you know that a kilogram meter per second squared, that is a Newton? So we're back to Newton meters. Okay, we're good. We're at joules, right? Need to be careful. Make sure you know the Newton is a kilogram meter per second squared. How do I remember that? F equals ma. A Newton is equal to a kilogram meter per second squared. That's how I remember Newton. It's kilogram meter per second squared. Kinetic energy is 1/2 mv squared. So this would have units of kilogram meter per second squared. Do you see that is a kilogram meter per second squared times a meter? So we're still at a Newton meter. We're still at a joule. So we're good. Heat energy just can be in joules. Okay. Briefly in English units, the main thing is just be consistent. Be consistent. If we're in foot pounds, keep everything foot pound, everything foot pound, everything foot pound, everything foot pound. Or if it might be in, pound inches, right? Everything. We could be in BTU. There's a conversion from in the textbook for BTUs. I will let you have a unit conversion sheet on your test, I believe, in this class. Yes. Okay. And so you can look at that conversion sheet. Main thing is be consistent. I'll just say be consistent. I might give you a handout on mass slugs, pound force, pound mass. But the main thing is be consistent. With SI units or with English units, be consistent.